Michael, over to you.
Thank you, Rachel, and thank you everyone for making the time today. Today we're sessions that regard Introduction to the Digital Research Alliance of Canada. Before I begin, let's just do a land acknowledgement. The University of British Columbia, the Point Grey campus is located on the traditional, ancestral, and ceded territory of the Musqueam people, and the University of British Columbia Okanagan campus lies on the ceded territory of the Syilx peoples. So as a quick overview of what we'll be discussing today, a little bit about the Digital Research Alliance of Canada, and then we're going to go over some of the computing services that they offer, and then other services that they offer in addition to the computing services, and then the training and support that's available to support all these services that we are going to discuss. So Digital Research Alliance of Canada. Digital Research Alliance of Canada, also known as the Alliance, serves Canadian researchers with the objective of advancing Canada's position as the leader in the knowledge economy on the international stage. So they provide infrastructure activities to support ARC, so that's Advanced Research Computing, Research Data Management, also known as RDM, and Research Software, RS. There are regional partners as part of the alliance. So there are AceNet for the Atlantic provinces, Calcutta, Quebec, Compute Ontario, and BCDRI Group. So these are institutions across the four Western provinces. So the role of the alliance. So the alliance serves a leadership role in national scale initiatives, so including the resource allocation competition, or the RAC, which we'll discuss a little bit more later, procurement, coordinating research data management, and other national services, securing funding, advocacy, and then national and international partnerships. The role of the regions, which we saw on the map, coordinate local activities such as training, staff management and ensuring needs of the institutions and provinces are being met. Something to note is that the Western Canada, so the four provinces on the west side of the country, does not have a regional organization. Instead, institutions collaborate individually between the universities. So to begin, the compute resources, which is what most researchers know the lines regarding. We first a little bit of defining some definitions. Academic principal investigator. To academic principal investigators, the role within the alliance. So it includes faculty. You're a full-time or part-time faculty member at a Canadian university, college, or research hospital. Adjunct faculty, or you're a librarian. And why that is something that I would like to flag is because all academic principal investigators can access the Federation of the Alliance resources and services, are eligible to request resources via the Rapid Access Service, something we'll expand on in a couple slides later. It's also eligible to apply to the Resource Allocation Competition, the RAC, and they can also sponsor users. So once a principal investigator has access, they can sponsor all their students, their collaborators, whoever they're working with on their various projects. To begin, you need an account. So an Alliance account, or also known as CCDB account. You go to this link on the slide right here, ccdb.alliancecan.ca, and you go to near the bottom right, there's a register link where you can, if you don't already have an account, you fill out the form. And this is the same form whether you are a sponsored, if you're applying for a sponsored account, where you would then provide the code from your principal investigator, or if you're principal investigator and you're just applying for your own account. So the compute clusters, the resources available through these compute clusters include Central Processing Unit, also known as CPU, Graphics Processing Unit, also known as GPU, and High Performance Storage. And some of the use cases for these compute clusters include any Python workloads, ANSYS, OpenFOAM, also parallel programming, and also anything that some of the interactive workloads, including if you use Jupyter Notebooks, virtual desktops, and things like that. For a little bit more information regarding these use cases and how to run these workloads, you can go to the documentation links below. In addition, so these clusters have all these resources and they're available across the country. So we have FUR, which is at Simon Fraser University, so on the West Coast. We also have NIBI, Norvell, and Rockwell. We also have clusters that's designed specifically for parallel jobs called Trillium. To request access to these clusters once you have an account, is go to the same link that we went to before to request for an account, log in, and you go to the tab at the top, Resources, Access Service Systems, and then click on the cluster that you're interested in using. And then you like the screenshot down below, I request access. In some cases, especially the ones that are based in Quebec, there are some terms, legal agreement or terms of use that you have to agree to, and then you submit your request, and your access should be automatically provisioned within an hour or so. Well, once you have access, how do you use these resources? How do you access these resources? The first way of doing that is through SSH, so through the terminal, using the cluster name and your username. Something to flag is the username is the 8-character, 8 alphanumeric name that you chosen when you register for your account, and not the code that is in the form of what I have there, ABC123-01, which is also known as the CCRI. So it's the alphanumeric code, like here, J Smith. And you log in with an SSH key or a password. In addition, you also have multi-factor authentication, whether you use a YubiKey, which is a physical USB compatible device that you can plug into your computer, or Duo, which is a mobile app. And here's an example of how you would do that on a terminal. Alternatively, you can also access these resources through a graphical user interface or through your preferred web browser. So in some clusters, notably FUR and Rockwell, you can use what is called Jupyter Hub, where you can run Jupyter Notebooks, and then you can run VS Code, RStudio, and some other software you see on the screenshot in the bottom left corner. And so you can interact with these resources without using the terminal. In other compute clusters, such as Trillium and NIBI, it uses a different graphical user interface called Open On Demand, where you could also access RStudio Server, Jupyter Lab, and things like that. But it's also through your preferred web browser. Something to note about Open On Demand is also the interface that we have here at UBC for our local cluster sockeye. In addition to compute clusters, the Alliance also offers the cloud, or in some cases, maybe refer to infrastructure as a service, where researchers can launch their own virtual machine to host things like data portals and things like that. So there are two to three different types of virtual machines or remote machines that you can use for your research. The first one being persistent instances. So it has less compute power, but it's intended to run indefinitely. So it runs 24/7. You're not planning to shut it down during overnight or anything like that. It supports things like data portals where you may have collaborators accessing it around the world. So there's no time when you want to shut it off, or database servers. The second type of machines that you could spin up include compute instances, where you have higher CPU and memory power than persistent instances. Compared to persistent instances, these are intended for a limited time. So according to the terms of use, intended to run at most for a month, because it's intended for things like fine-tuning computational workloads. So once the workload is complete, it's intended to shut it off so that other researchers can make use of that resources, and then you can start it up again when you need to run your when you need to fine-tune your workloads again. Last but not least, there's also GPU. A small amount of GPUs on these cloud clusters. Arbutus will offer H100 GPUs in one size, which is listed there, which has 12 gigabytes of GPU memory, 3 CPUs or 3 cores, 35 gigabytes of CPU memory, and 125 gigabytes of ephemeral storage. There are other larger or other sizes or GPU flavors available for rack, which we'll get to in a second, recipients, and those would be shared during the rack competition. And some of the use cases for these virtual GPUs in comparison to the GPUs available through the compute clusters include real-time interactive needs, access directly from a science gateway. So you, for example, your collaborator or yourself will log into your preferred web browser and you interact with it, and it's running, these GPUs are running in the background. Environments or software that do not easily integrate into HPC environments. So there are software that doesn't work well with the high performance computing cluster architecture, and also fine-tuning computational workflows. And something to note, it's coming soon, so it's not yet online at this moment, but it will be coming online, and the announcement will be going out as soon as they're available. Storage. So through the cloud, there are 4 types of storage available. Volume storage, so this is a standard type of storage that most people think of when they hear the word storage for the cloud. So they're essentially like a drive or like a C drive or that type of drive that you have on your computer, but this will be connected to your to your virtual machine. The second is ephemeral storage, which we briefly mentioned in the with GPUs. So these are storage that are tied to the compute. So whether any of the GPU or CPU compute, they're intended for temporary purposes, so intermediate file, things like that. And the data stored on there will be gone once you shut off the machine. Object storage. So these are ideal for storing, archiving, backing up, and managing high volume of static and structured data, similar to the AWS S3 that you may have heard of. And last but not least, are the shared file system storage. These are a common use case for this type of storage is when you have a storage to store data that may need to be, and the data needs to be used by multiple machines. And so this type of storage is designed for that purpose. If you want more information about these type of storage, and also there's a comparison table at the link at the top right corner. So we talk about these all these cloud resources. Arbutus is the largest cloud site, so it has the most resources of the type we just discussed. It's hosted at University of Victoria. It's based on Linux. So all the virtual machines that we just discussed spinning up, whether it's GPU or persistent or compute, they're all Linux based. So you have all the common Linux operating system you can choose from. To access these resources, you can apply anytime for a Cloud RAS, which has certain limits of compute and storage that you can ask for, but any time of the year at the link. At the first link there, so there's a table where you can see all the limits, but you can request at any time, and usually you'll get access to that project within around 2 working days. Now, if you already have an allocation or you have a new student joining your lab, you could, to request access to the existing allocation or project, you just need to email that email address right there. And to get started on how to launch these virtual machines, there's a quick start guide at the link below. So this is a screenshot of the dashboard you'll see for the cloud, and you access that through your preferred web browser. So you have a dashboard of the quotas, the resources you have available to you, and then you also launch your virtual machine through this dashboard. And this is the link at the top there is the example, because this is the link to the Arbutus cloud, but the link will slightly differ for the other clouds across the country. computing services. So we discussed the high computing clusters in the cloud. So they all have default allocations, default quotas. Now, if you need more, there is a competition, the resource allocation competition, also known as the RAC, that runs every year in the fall. This year's competition ended earlier this month. So you could ask for more than the limits that are expressed in any of those RAS allocation. So you apply in the fall, and then what it is then awarded the first of in the beginning of April. During these competitions, we recommend contacting UBC ARC for consultations at least 1 week before the deadline, and we can provide some advice on how you can fine tune your application to maximize the likelihood of you getting the resources. And for more information, there's a link at the bottom there. In addition to the compute cluster in the cloud that we just discussed, there's also 3 AI clusters available across the country. They're listed there. They are part of the Pan-Canadian AI compute environments. So to be eligible to access these resources, in addition to being the eligibility requirements that we discussed earlier, you either have to be a Canada CIFAR AI chairs and equivalent and their research team, AI Institute faculty affiliates, so affiliated with one of the 3 institutes that we shared the last slide, a faculty member with a tenure track appointment at a Canadian university within the AI program, or a faculty member with a tenure track appointment at a Canadian university applying AI to other domains. And so once you're determined you're eligible for at any of these criteria, you can again go to CCDB, the same link that we shared earlier during this session. Go to resources, access systems, same as compute cluster, but you choose artificial intelligence. You see the tab in the screenshot below, and then you choose the clusters that you're interested in, and then you request for access. But slightly different, there might be a little bit longer turnaround time than the compute clusters. And there's a second step to this where you have to request general access to these systems, where you're essentially saying that you are doing research within an AI program or applying artificial intelligence models in your research. So there's 2-step process for these AI clusters. In addition to all these different compute resources, there's also a quantum computing service available. We have named Monarch. It's a 24-qubit superconducting quantum computer. Some of the common use cases include computations requiring small quantities of high fidelity qubits, modeling small quantum systems, and testing new methods and techniques for quantum programming error corrections. For more information, there's documentation at the link below, and this quantum computer is based in Quebec. And here's the link to request for more information how to request for access, and the support email also on the slide. Other services. So the Alliance also offers other services to support researchers across the countries. First, we have Nextcloud. So Nextcloud is a Dropbox-like cloud storage service. So like Dropbox, you can store some files there, and you can share files with your collaborators, with your lab. You also can collaborate on documents. So you, at the link there on the slide, you can go to the link and log in with your Alliance or CCDB account, and you will have access to up to 100 gigabytes of storage. And for more information about this service and also how to use this service, there's documentation at the link at the bottom. Globus. So Vault is a service for fast and reliable, secure transfer of files, especially useful for if you're transferring or sharing files that are large in size. So transferring data and sharing data are the two most common use cases with Globus. They are also the recommended way of transferring data back and forth from all the clusters that we discussed. If the cloud is also available for the object storage. So you can access the object storage through this Globus service. And to access it, you can log in at globus.org with your Alliance account. You can also log in with your institution account, such as UBC CWL. For more information and documentation, there's documentation at the link below. Next, we have the database service. So the Alliance offers access to MySQL or Postgres database servers for researchers. So, for example, some use cases include if you use an extension, a Postgres extension called PostGIS for geospatial data, that's available along with the Postgres database. And also if the database is used for in conjunction with your HPC workflow, so with some of the compute clusters. To request access, email cloud@tech.alliancecan.ca, and for more information at the link below. So this is an alternative to spinning up your own virtual machine and hosting your own database, where you will have to maintain the security updates yourself versus using this service, all the security updates are maintained by the Alliance. So we also, beside all the compute and storage and data driven services, we also have Alliance also has services for research data management, or RDM. So first, there's a DMP Assistant. It's bilingual. It's a bilingual tool for preparing data management plan. So this is data management plan is becoming a requirement for a lot of research grants. So this is a tool to help researchers to put data management plan together. To access it, you can log into at that link there on the slide of your UBC CWL. For more information about the service, you can go to the link below. Next, we have the Borealis, the Canadian Dataverse repository. It's also bilingual, multidisciplinary, secure Canadian research data repository. So this is one of the places you could use to make your data available to the public, to your collaborators, is through Borealis. And for more information, how to access, go to borealisdata.ca. For more information and for support, you could go to the documentation at the bottom of the slide there. And also, UBC Library also has resources for this particular service at the link there as well on the slide. Further, it's also known as a Federated Research Data Repository. It's a national bilingual platform for sharing or preserving Canadian research data. So it's intended for large research data sets. And so it's for ingesting, creating, processing the data for preservation, discovery, citation, and to be shared. Similar to the other services, you can log in at the link there on the slide with your Alliance account. And then for more information about the service and documentation, the link at the bottom of the slide will bring you there. Lunaris is Canada's national discovery service. So the services we just discussed is for data preservation, for sharing. Lunaris is to support the discovery, so for others to find your data. So data sets from over 150 academic government research repositories are made discoverable on this bilingual interface. For more information and to access this discovery tool, you can go to those links there on the slides. Yes, thank you, Marjorie. Yes, that link is also very helpful. And this comes to the end of the presentation. So with all these resources that we just discussed, there are training that's available through UBC Arc here. So to see what are the upcoming training sessions, you can go to our training calendar at the link there on the slide. You can also, as Rachel mentioned, all the sessions we are offering are recorded and uploaded to our YouTube channel at the link there on the slide as well. And speaking of the regions, at the beginning of the session, where they also offer training uh, across the country, they are also made discoverable on this tool, Explora, the Alliance Training Catalog. So you can find other training resources, training sessions that are available year round, and you can pick the ones that work best for your schedule. If you have any questions about any of these services, you can contact UBC ARC support at arcs.support@ubc.ca. You can also contact Alliance support at support@tech.alliancecan.ca. With that, that's the end of the session. I can help answer any questions. But before I do, I just want to share the slide. So we would love your feedback. So if you could take a few minutes, would be greatly appreciated to complete this short survey to let us know how we did. And we also have a draw at the end of the month for any one that provides feedback through the survey at this QR code on the slide. With that, I can answer any questions that you may have. Thank you, Mina.